Hello dear friends, myself Sonigra, and today in the subject of mechanical drafting we will cover a chapter titled as Projections and Sections of Solid. In this chapter we will discuss about the solution of various examples, some basic concepts and some objectives of today's discussion covers. The first objective for today's presentation is to understand the concept of projections of solid and to solve the examples based on cylinder and prism. So today we will cover two solids, namely prism and cylinder. So these are the objectives for today's discussion. Projections of solid. Now what do you mean by projections of solids? Before that, let me discuss what is solid. A solid is a three-dimensional object having length, breadth and thickness. It is completely bounded by a surface or surfaces which may be curved or plane, or they may be inclined or at any angle. Solids can be classified into mainly two categories. The first is prism and cylinder. A solids having top and bottom base of same shape, they are covered into prism and cylinder. Prism and cylinder are the examples of category 1, and in category 2, pyramid and cone, solids having base of some shape and top as a point, called as apex point, means the solid which is having a regular base, it may be circle or any polygon, and apex point as a simple one point. These are the solids. Say prism, hexagonal prism and a cylinder comes into category 1, and this is category 2, cone and a pyramid. It's a pentagonal pyramid, it is having pentagonal base. Classifications of solids. We can classify the solids into two groups as we have discussed. Group 1, solids having top and base of the same shape, that is covered into group 1. Group 2, the solids having base of some shape and just a point at the top, which is called as apex point. In group 1, the examples are cylinder like this, prisms, it may be of various shapes like triangular prism, square prism, pentagonal prism, hexagonal prism. Based upon the type of polygon, the prism is named. Cube. What do you mean by cube? That is also solid, belongs to group 1. A solid having 6 square faces, it is called as cube like this. All faces are of equal area and are square by shape. In group 2, cone like this, having a circular base and apex point, and a pyramid means a regular polygon at the top, at the bottom, and apex point at the top, like this is a triangular pyramid, square pyramid, pentagonal pyramid and a hexagonal pyramid. Similarly, tetrahedron. Tetrahedron means which solid? It's a solid having 4 triangular faces like this, and all triangular faces are of equal sides and equal area. All are equilateral triangles. That is called as tetrahedron. Now dimensional parameters of solids. Which are the parameters which are used to show the solid? For square prism, square pyramid, cylinder and cone, these are the parameters. These are 4 solids, and this is called as the top face of the solid. This is called as the rectangular face, and these are the longer edge or edges. This is the corner of the base, and this is the edge of the base. These are the nomenclatures for square pyramid, square prism, and this is a square base. So in this square prism, 2 parameters are needed to represent a square prism, that is, one is its height and another is its side length of the base. As it's a square prism, so all sides would be having equal length. So 2 parameters would be needed to represent this square prism. Similarly, for square pyramid, This is apex point, topmost point. This is called as slant edge. This edge is called as base. This is edge of the base. This one is the corner of the base, and this is a triangular face. As it's a square pyramid, 4 triangular faces would be there. So to represent this square pyramid, again 2 parameters are necessary. One is the side length of the base and another is its height. Now regarding these type 2 solids belongs to group 2, that is cylinder and cone having curvature shape. So it is not having edges. So to represent the edges, we draw imaginary generators like this. These are the imaginary generators. Generators are imaginary lines generating curved surface of cylinder and cone. That is called as the generator. And generally, to draw the projections of such kind of solids having curvature shape, we draw the generators. And this is called as the base. This is apex point. This is again a square base as it's a cone. Now what is this? If we cut the cone in the front view at certain angle, it would be visible like this. So these are called as the frustum of cone. Second is the cylinder. This is the square pyramid. And sections of solids, top and base not parallel. The cutting plane is not parallel to the base, and hence it would, if we cut along its certain angle, it would appear as represented over here. This is the frustum in which the cutting plane is parallel to base. So it is called as frustum. It's a cone and square pyramid. Frustum of cone and pyramids, top and base parallel to each other. So that is the solid. Now simple examples based on projections of solid. The first one, a hexagonal prism of 25 mm base edges and 50 mm height, having 2 of its vertical rectangular faces parallel to vertical plane and its base resting on horizontal plane. So in this example, a hexagonal prism is given. 25 mm is the side length, 50 mm is the height. Now how to draw the first step of such kind of problem? So for that, we start from its top view, as it is resting on HP and its vertical rectangular faces are parallel to VP and base is resting on HP. So from first we have to draw its top view, which is below XY line, and it's a hexagon, and here it is given that 2 rectangular faces are parallel to VP. So we have to draw its top view like this. 2 faces are parallel to vertical plane, means this ED and AB and ED both are parallel to XY line. So first we have to draw this hexagon below XY line in such a way that 2 sides are parallel to XY line, and this is the side length 25 mm given in this case. After drawing this top view, we take projection from each corner A, B, C, D and E, draw vertical lines and draw here rectangle in such a way that its height is 50 mm and width is equal to width of this F to C distance. So this is the simple example of hexagonal prism. Now if in the example it is given that 2 sides in this here vertical rectangular faces, these are not parallel to VP but are perpendicular to VP. So in that case we have to draw this hexagon in such a way that 2 sides are perpendicular to XY line. Now one more example, a triangular pyramid with 30 mm edges at its base and 35 mm long axis resting on its base with an edge of the base near to vertical plane and parallel to and 20 mm from vertical plane. The base is 20 mm above horizontal plane. So here a triangular pyramid is given, hence its top view would be triangle, its front view would be triangle, and in top view the triangle's side length are given to us, that is 30 mm, but here it is given that the axis resting on base with an edge of the base near to VP. So we have to draw its front view in such a way that the apex point should be nearer to VP and parallel to and 20 mm from vertical plane. It is at a distance of 20 mm from VP, and base also it is given that the base is 20 mm above HP. So its front view would be 20 mm above XY line, and the solution would be like this. This is the solution for this problem. In top view, it's an equilateral triangle of 30 mm sides. You can represent its side length 30 mm, and by taking projections from A, B and C, project it over here. Further, it is given that the edge on which it is resting is at a distance of 20 mm from VP. So this distance should be kept 20 mm from XY line, and further it is given that the base is 20 mm above HP, and hence this A dash B dash represented over here is at a distance of 20 mm from XY line. So I hope the solution of this problem is clear to you. Third example, a square pyramid of sides 40 mm and height 50 mm. Here square pyramid is given, axis perpendicular to vertical plane. This is one more data it is given. Axis is perpendicular to VP and the vertex is away from VP. Its vertex, that is apex point, is away from vertical plane. Draw top view and front view. As here it is given that axis is perpendicular to VP, we have to draw its true shape in front view as a square. So its front view would be a square, and this would be the solution. In front view, it would appear as a square having side length 40 mm. So first we draw this square in the front view having side length 40 mm, and two sides are parallel to XY line. And by joining these two diagonals A dash C dash and B dash D dash, we can find out the apex point, or it is called as the vertex point O dash. From this vertex point O dash, draw a center line like this, and this is the base and height is 50 mm, which is given in the data. So from locate this point and draw this triangle, and this is the solution for given problem. So all these problems are simple problems which is the first step to draw any problem based on projections and sections of solids. Now let me discuss some typical examples. One case, axis is parallel to both the reference planes. In the previous discussion, we have seen that the axis is at a right angle to HP and right angle to VP. But if it is given that the axis is parallel to HP and VP, what should be its view? Then let me see that. This is the case in which the axis of this triangular prism is parallel to horizontal plane and parallel to vertical plane. So how to draw projection of such kind of problems? So in this problem, we have to start the solution from its side view, because once the axis is parallel to both the reference plane, its side view represents its true shape of its polygon. So in this case, triangle is the polygon. So the solution would be like this. We start from this side view would be triangle, and by taking projection from this side view, length of the solid would appear in front view and top view, and we can represent three views of this solid like this. So if any problem, if it is given that axis is parallel to both the reference planes, we have to start from its side view. The polysolid may be cylinder or cone or any regular prism, say hexagonal prism or pentagonal prism. Now example number 1. After discussing this theoretical background, let me discuss some problems based on these sections, these projections of solid. The data is given like this. A pentagonal prism with its edge of the base 20 mm and axis 50 mm rests on one of its rectangular faces with the axis perpendicular to the profile plane and parallel to HP and VP. Here pentagonal prism is given. Draw the projections of prism. Side length and base is given, and it rests on one of its rectangular face. So this is a pentagonal prism which is given in the data, and it is resting on its rectangular face, and its axis is perpendicular to that rectangular faces with the axis perpendicular to profile plane and parallel to HP and VP. So it is the case which we discussed in the previously, like this. This is the data. So first of all, draw XY line. Here it is given that its axis is parallel to HP and VP. So we have to start from its side view, and side view would be a regular pentagon having base parallel to XY line. So first we have to draw a pentagon, and from the base of this pentagon draw an XY line. So that is the side view of given data. Now from this side view we take projections. So this projection will represent its front view like this. Length is given to us, that is 50 mm. So this side length is 20 mm and this length is 50 mm. And this edge would be visible, hence it is represented by full line, and the top view would be below front view, and that is again our rectangle. This is the edge, and these dotted lines represent this bottom edge. You can see here this edge and this edge is not visible in the top view, so it is represented by dotted lines like this. So this is the top view of this problem, like this. Now let we draw this problem on our drawing sheet. So here, how to start the problem? So first, practically you should draw XY, theoretically you should draw XY line, but for the better practically we will draw a pentagon over here of given side length, that is 20 mm. So first draw a pentagon having side length 20 mm. After that draw a XY line like this, and after drawing this XY line, draw this meter line which makes an angle of 45 degree with XY line. This angle is 45 degree. Now after that take projections from these 5 points A, B and C, A, B, C and D. Name the endpoints. So this is endpoint A, B, C, D, E. As it's a side view, you can name dash or 1 as per the conveniency. From all these points take projections like this. Horizontal line from point E, horizontal line from point